Good morning, children. So we have been doing the midpoint theorem and we had done till question number 4. Now we will see question number 5. So here you can see question number 5 is in figure 9.21. So here is the figure. ABC is an isosceles triangle. So we have already learnt about the isosceles triangle. Isosceles triangle means two sides are going to be equal. So in which AB is equal to AC. So for this triangle, AB is equal to AC. Clear? And further they are saying that D, E and F, okay, D, E and F are respectively the midpoints of sides BC, AB and CA. Okay. Show that the line segments AD, EF bisect each other at right angles. Okay. So we are supposed to show that this angle is 90 degree. Okay. So for that what we are going to do is, firstly we will join DF and D. Now as they have said that this DEF, these are the midpoints. So that means as E is the midpoint of AB, so here AE and EB will be equal, and F is midpoint of AC and also AC is equal to AB. So first of all AF equal to FC, and since AB and AC are equal, therefore AE equal to AF. Clear? And now what we will do is, here you can see that D and E are midpoints. So when you join these 2 points, so you get D parallel to AC. Okay, that means D will be parallel to AF. And when you join DF, you see that D and F are midpoints. So in that case, DF will be parallel to AB. That means parallel to AE. Okay, and this DF will be half of AB. That means it will be equal to, this DF will be equal to AE. Okay, and DE will be half of AC. That means D will be equal to AF. Okay, so here you observe that AEDF, it is a parallelogram. Opposite sides are parallel and also opposite sides, okay, in fact all sides are equal. So if you have a parallelogram where all the sides are equal, so that is called rhombus. Okay, and we know that diagonals make 90 degree in rhombus. Okay, so therefore proof is over. So this was simply an explanation. Now I will show you how you are supposed to write down. Okay. Okay children, so this is what you are supposed to write. So here we have been given that D, E and F are the midpoints of BC, AB and AC respectively. Okay, and AB is equal to AC. Why AB is equal to AC? Because they have said that this triangle ABC is an isosceles triangle and AB is equal to AC. Okay, so these are given to us. Now construction, what we are doing, we are joining DE, okay, and DF. Okay, and once we have joined them, now by midpoint theorem, okay, by midpoint theorem what you observe is this DE, okay, will be parallel to AC, okay, and this DE will be half of AC. That means D will be equal to AF, and also since D is parallel to AC, therefore D is parallel to AF. So D is parallel to AF. Clear? and your DE will be equal to AF. So this much is done. Now next, again by midpoint theorem, your DF is going to be parallel to AB. Okay, it's going to be parallel to AB, and DF is going to be half of AB. So here DF is parallel to AB and DF is half of AB. Half of AB is AE. Okay, and since DF is parallel to AB, therefore DF is parallel to AE also. Okay, and therefore DF is parallel to AE, sorry, equal to AE. Done. So thus DF is equal to AE. So here DF is equal to AF. Okay, and that is equal to AE. So why I am saying that AE is equal, AF is equal to AE? Because AB is equal to AC, because this triangle is an isosceles. ABC is an isosceles triangle. Okay, so then we are getting D is parallel to AF and DF is parallel to AE, and DE is equal to AE is equal to AF equal to DF. Okay, so here what we are getting? We are getting opposite sides parallel and all the sides are equal. Okay, so therefore AEDF is a parallelogram, and as sides are equal, as you can write as all sides are equal, hence it is a rhombus, and we know diagonals of a rhombus bisect at 90 degree. Okay, so what you will do is you will pause the video, okay, and you will copy this. Done. So you can simply pause the video and you can write down. So I'll just rub this. Okay, here you can add all. So this is how you are supposed to do this question. Now we will see the next question. Okay children, now let us see question number 6. So here it says, prove that the 4 triangles formed by joining the pairs of midpoints of the 3 sides of a triangle are congruent to each other. So here it's trying to say that, let's say you have one triangle A, B, C, and let's say midpoint of AB is this, midpoint of AC is this, and midpoint of BC is this. So we will, when we'll join these, okay, these midpoints, we will get altogether 4 triangles, 1, 2, 3 and 4. Okay, so what we are supposed to show is, we have to show that these triangles are congruent. Okay, means exactly same, okay, in all respect. Getting it? So we have already done congruency. Okay, so it won't be tough to show, but here we need to make use of the midpoint theorem. So what I will do is, we will just move on to the solution part. Okay, okay children, so here you can see this will be your diagram. Okay, ABC is the given triangle, and then here D is the midpoint of AB, E is the midpoint of AC, and F is the midpoint of BC. So we are joining these midpoints, okay? And now if you see this one, okay, since D, E, F are midpoints, so since D is the midpoint of AB, so this AD, okay, will be equal to DB. E is the midpoint of AC, so here we have this A is equal to EC, and then here F is the midpoint of BC, so we'll have BF equal to FC, okay. Now what we are going to do is, when we join this DE, so what we observe? We observe that this DE will get parallel to BC and DE will be half of BC, okay. Half of BC means DE will be exactly equal to this FC, or you can say equal to BF. So that's why I'm denoting by same symbol, okay. And next, when you join D and F, okay, in that case your DF will become parallel to AC and this DF will be half of AC. That means this DF will be exactly either AE or EC, okay. So that's why same symbol over here. Now when you join FE, in that case your FE will be parallel to AB, okay, and FE is going to be half of AB, okay. So that's why I have used this symbol. Done. Now what you observe that if you consider this triangle ADE, okay, so here, like whatever is the length of this side, okay, in fact you can see these all four triangles, okay, they have you can see sides, no, are equal. Like here, if I'm take this 1, this is 2, this is 3, this is 4. So if you try to compare triangle 1 with 2, then you'll see that this side is equal to this is equal to this one, and this side is equal to this, okay. So with others also you can see that, okay. So here let's see what you're supposed to write. You'll write given, then you write DEF are the midpoints of AB, BC and AC respectively, okay. So you'll write down this. Now let me rub this, I've already explained to you, okay. So you'll write down, you'll draw this, and then you'll write by midpoint theorem we have, like here DF, okay, DF, D and F are midpoint, so DF will be half of BC, okay. Here this is not DF, D, sorry. So D, so this is D, so this D will be half of BC, okay, and this will be equal to BF or FC. Done. And D will be also parallel to BC. And next FE will be equal to half of AB here, FE, okay. This is going to be half of AB. That means FE will be either equal to AD or DB, and FE will be parallel to AB, okay. And then your DF is going to be half of AC, okay, or you can say DF is exactly AE or EC, and DF will be parallel to AC. So you got these three information, okay. Now from 1, 2 and 3, okay, and from the figure you will see that these triangles are going to be congruent. Why? Side, 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 okay. So here, like after labeling 1, 2, 3, 4, I was trying to explain that, like for 1 and 2 if you compare, this side is equal to this one is equal to this one is equal to this, so side, side, side. Same way if you compare 1 and 4, again you get here one, here this side is equal to this is common, okay, and this is equal to this. If you try to compare 1 and 4, 1 and 3, you can do the same, okay. So here all the triangles, all these 4 triangles are congruent by side axiom of congruency, okay. So you will copy this. For that you have to pause the video and you will copy it, okay. So this question is over. Okay children, so now next question, question number 7. This will be your homework. So here it says D, E and F are respectively the midpoints of sides BC, CA and AB of an equilateral triangle ABC. Prove that triangle DEF is also an equilateral triangle. So here actually it's trying to say that you have a triangle ABC which is an equilateral. When we say it is an equilateral, that means all sides are equal, okay. So here your all sides are equal, that means AB is equal to BC and BC is equal to CA, okay. Now here it's saying that if D is the midpoint of BC and E is the midpoint of C and F is the midpoint of AB, so in that case when you join these midpoints you are getting a triangle, 4 triangle actually, and here you see that this middle one is triangle DEF. So they want you to prove that this triangle is also an equilateral. That means you need to show that this FE is equal to D is equal to FD, means all sides are equal. You need to show that, okay. So here you are going to use the midpoint theorem, okay, and you can easily prove that. So this is going to be a homework and you will do it by yourself. Now I am going to see question number 8. So here question number 8 says in figure 9.22, so this is the figure, AD and BE. So AD, so this is your AD and BE are the medians. So now firstly you need to understand what is median. So here this is your A, this is your B, this is your C. Let's say this is the midpoint of BC. So if I join this vertex A with D, then this line AD will be called median, okay, to BC. Now let's say this E is the midpoint of AB, okay. If E is the midpoint of AB, then this line which you get on joining E and C is called median to AB, okay. So here it's saying AD is median, that means D is nothing but midpoint of BC, and next is saying that B is the median of this AC. So in that case AE will be equal to EC, clear. Now what we are supposed to prove, we need to prove that CF, that means this length is equal to 1/4 of AC, okay. So let us see the solution. Okay, so here question number 8, this is the figure, okay. They have already said AD is median and B is median. In that case this D is the midpoint of BC and E is the midpoint of AC. So here given AD and B are the medians of triangle ABC and BE, okay. So here is saying that BE is parallel to DF, okay. So these things are given to us. Since BE and this AD are medians, therefore D will be the midpoint of BC and E will be the midpoint of AC, clear. Now as D is the midpoint of BC, okay, like this is the midpoint of BC, and also this DF is parallel to BE. So by converse of the midpoint theorem, this F will be midpoint of EC. Okay, EC, because here we are considering this triangle BEC. We are considering this triangle where D is the midpoint of BC. Okay, and here we are drawing one parallel line through D. Okay, which is parallel to what? B. So in that case, by converse of midpoint theorem, this F has to be the midpoint of EC. That means I'm trying to say that this and this length will be same. Okay, so here that's what I'm trying to write, that as D is the midpoint of BC and DF is parallel to B. Okay, so in that case, by the converse of midpoint theorem, we have F is midpoint of EC. Okay, so therefore we get CF equal to half of EC. Yes, since F is the midpoint of EC, therefore CF will be nothing but half of EC. So we have written, but you can see that as E is the midpoint of AC, therefore this EC is nothing but half of AC. Okay, so in place of EC I can write half of AC. Okay, so half of AC I have written. Now we simplify and you are getting CF equal to 1 by 4 AC. Okay, so this proof is done. So what you can do is you can just pause the video and you can copy it. Okay, so this is parallel. Done. Okay, now we'll see next question. Okay children, so now we will see the last question for this exercise. Okay, we shall not do any more questions. So here question number 14 I will discuss, and with this question this chapter gets over. So here question 14, here you can see that it's saying ABCD is a parallelogram. Okay, so here they are talking about figure 9.24. So here they are saying that ABCD is a parallelogram. So ABCD is a parallelogram. That means the opposite sides are going to be equal. That means AB is equal to DC and they are going to be parallel. So AB equal to DC, AD is equal to BC, and they are parallel to each other. Now next it's saying that E is the midpoint of AB and F is the midpoint of CD. So here it's saying that E is the midpoint of AB and F is the midpoint of DC. So in that case, since E is the midpoint of AB, so AE will be equal to EB, and for F here midpoint F is the midpoint of DC, so DF is equal to FC. Okay, and next is saying that GH is any line that intersects AD, EF and BC in GPH. So here there is one line, you can see the GPH, this is line which intersects AD at G and EF at P and BC at H. Now they want us to show that this GP is equal to PH. Okay, so now let us see how we are going to show it. Clear? So here question number 14. Okay, so given ABCD is a parallelogram, so ABCD is a parallelogram. That means AB parallel to DC and AB equal to DC, AD equal to BC and AD parallel to BC. So since it's a parallelogram, so I can write BC parallel to AD and AB parallel to DC. Okay, and BC will be, since it's a parallelogram, so AB will be equal to DC, opposite sides equal, and AD equal to BC. Now next they have said that E is midpoint of AB and F is midpoint of CD. So these are given to us, so I am writing it down. So now as it's saying that E is the midpoint of AB and F is the midpoint of DC, and you also know that AB is equal to DC. Okay, so therefore this AE will be equal to DF. Okay, AE will be equal to DF. Okay, and therefore this FE okay, this whole line from here till here, this FE will become parallel to AD. Okay, so here I am trying to write that, therefore AE equal to DF. So AE equal to DF. Why? Because E and F are midpoints and AB is equal to DC. Okay, and also this AD will be parallel to EF. Okay, since ABCD is a parallelogram. Now we are supposed to show that GP is equal to PH. So for that we are doing some construction. And what is the construction? We are joining G and B. Okay, we are joining G and B, and I am here, you can see that this is intersecting EF here, so I am naming it as K, So here construction join GB. Okay, now for triangle ABG, so I am going to consider this triangle. I am going to consider this triangle ABG. Okay, so I am considering this triangle. Okay, so in this triangle, what do we observe? That E is the midpoint of AB, so that means this A is equal to EB, and we have observed that this EK is parallel to AG. So therefore, by the converse of midpoint theorem, this K will be the midpoint of GB. Okay, that means this KB will be equal to KG. Okay, so that's what I'm writing over here, that after joining we are considering this triangle ABG, where E is the midpoint and AG is parallel to EK. So by the converse of midpoint theorem, K is the midpoint of GB. Just now I explained. Okay, and now what I will do next, I will consider this triangle. Next we will consider this triangle. Okay, so for this triangle, clearly you can see that K is the midpoint, okay, of GB, and this KP is parallel to BH. Okay, so in that case, by the converse of midpoint theorem, this P will be the midpoint of GH. Therefore, GP will be equal to PH. Okay, so I'm just rubbing it. So here next we'll consider triangle GHB. Okay, where K is the midpoint of GB and KP is parallel to BH. Therefore, by the converse of midpoint theorem, P is the midpoint of GH, and therefore GP is equal to PH. It's proved. Okay, so this is all for this chapter 9, and this you will copy, and for that you will just pause the video, okay, and you will write it down. Okay, so in the next class we shall start a new chapter. Okay. Okay children, so this is all for today.